Hello everyone, this question is about trigonometry. Part A, express 3 cos x plus 2 cos x minus 60 degrees in the form r cos x minus alpha, r positive, alpha quadrant 1, r in exact value, alpha into the p 4 marks. So first of all, we have this MF19 formula. We have to use this for cos x minus 60 degrees. So the A is x, the B is 60 degrees. We have cos plus sine. Make sure you can use the formula. It is plus, not minus, and you multiply by 2, and then use a calculator. Cos 60 is 1/2, sine 60 is root 3 over 2, and 2 times 1/2 is 1, 2 times root 3 over 2 is root 3, and 3 plus 1 is 4. So in the simplest form, we have 4 cos x plus root 3 sin x. Now we still have to express this in this form. So we use the formula again, cos plus sine. And now multiply the r. Now we analyze, we equate the coefficients. So for the variable cos x on the left, the coefficient is 4. On the right, the coefficient is r cos alpha. So r is a coefficient, alpha is also a coefficient because they are constants, they are not variables. So we have r cos alpha equals 4. And if we analyze the sine x variable, on the left root 3, on the right r sine alpha. So we have the second equation. Now if we divide both equations, r sine alpha is root 3, r cos alpha is 4. When we divide the two equations, cancel out the r, sine divided by cos becomes tangent. So we have tangent equals root 3 over 4, which means the alpha is inverse tangent root 3 over 4. In degrees to dp, 23.41 degrees. Now to find the r, the exact value of r, we can just square r cos alpha, which is 4, and r sine alpha, which is root 3. So we square and we add everything, because when we do that, we get r squared cos squared plus r squared sine squared. We can factorize the r squared, so cos squared plus sine squared happens to be 1 in the MF19. So of course we have to square the 4 and the root 3, and then we add. So r is the square root of 19. Now we have the r and the alpha. The next part, hence solve the equation 3 cos 2 theta plus 2 cos 2 theta minus 60 degrees equals 2.5. So first of all, we have this from the previous part. If you compare it with this guy here, it's using 2 theta, not x, not theta, but 2 theta. So since we have to modify a little here, of course we have to use 2 theta instead of x. So from the original equation here, we can replace this left hand side with this guy, because it's the same. So we use root 19 cos 2 theta minus, okay, so again it's 2 theta, it's not theta, it's not x, but 2 theta here. Then we divide by root 19. Now to find the base angle, we do inverse trigonometry. In this case we use cos. Remember, we have to use the positive value, ignore the negative if any. There's no negative here, so just inverse cos. We get the base angle or the quadrant 1 angle. Now if we look at the domain in the question, it says the theta is between 0 and 180 exclusive. So we can multiply throughout by 2, and then subtract 23.41 because the angle we are dealing with is 2 theta minus 23.41. So this means we can use angles in between minus 23 and 336. Since it's gotta be positive and it's cos, we can only use quadrant 1 and quadrant 4. Quadrant 1 is the base angle 55, quadrant 4 is 360 minus base angle. So for 2 theta minus 23.41, we get 55 or 305 plus 23.41 both sides, you get this. Divide by 2 both sides, we get this. And for the final answer, angles in degrees, we can just use 1 decimal place. So the final answer is 39.2 and 164.2 degrees. Right, I'll see you again next time.